What's up, YouTube? My name is Odi. I'm a software engineer. Welcome back to my channel. And today I'm going to be discussing showing benchmarks for the 7950X3D. If you haven't seen my previous video, you should really go check it out. In that video, I talked about the 7950X3D, the rationale behind it, how it's made up, the architecture, all that good stuff. So you should really check it out. Also, if you like my content, please give it a like, give it a subscribe. I really appreciate you. And yeah, I read your comments, I read everything, and I answer everything. In fact, today's video is actually inspired by a comment, and maybe I should just go ahead and read the comment. I'm going to also put the comment here. The comment is from, I don't know how to pronounce the username, but he asked, can I ask you about the way you set up your CPU? Are you using the AMD recommended core packing solution with proper drivers installed, or process lasso to enforce CCD0 is used while gaming? My second question is, comparing your earlier CPU, the 5950X, have you captured the performance difference in percentage? Thank you. Yeah, so thank you very much, Peter Nagy 665. Thank you for the question. And to answer your question, especially the first part, the answer is no. I just installed the drivers, installed the core packing feature. For those who don't understand, what he's talking about is because we have different CCDs, and one CCD has like extra cache for gaming. You want the games to be able to run on the CCD that has the right cache, and you want your regular applications that require higher clock speeds to run on the regular CCD. And for the most part, I would say in my experience, you don't need to worry about it. Just install the AMD drivers, the AMD chipset drivers in particular, and it just works out of the box. I can even show like a diagram of, what that looks like. But yeah, when you're running a game, it runs on the right CCD. And when you are doing your regular applications, opening Microsoft Word, documents, running code, whatever, that runs on the other CCD. You could use a software like Process Lasso, like he mentioned, but to me, at that point, it defeats the whole purpose of having a good CPU. And truth of the matter is that the difference in performance isn't that much to require you to go through, jump through hoops to do any of the CCD rigmaroling. I think just get it out of the box, install it, install the chipset drivers, and it will do the right thing every time. So yeah, that's my advice there. The second question was with regards to 5950X and the difference in performance. Well, there's good news here. That's the whole point of this video. I'm going to just go over the benchmarks. So let's take a look. So the very first benchmark we're going to look at is the code compile benchmark. In the code compile benchmark, it's just focused on what's the experience like when I just have I clone a project from GitHub and I just try to build it straight away. And you will see, the first thing you see here that is actually quite shocking is that the M1 Pro is actually for the F# compile, for example, is actually much faster than the 5950X, right? That sounds crazy. And the reason for this is that, single thread performance, the M1 Pro is really, really good in single threaded applications. So of course, the 7950X3D is still faster, but you can see right away that, there is just a huge performance gap between it and the 5950X. That's due to superior process node, and more importantly, I think due to the change in the architecture as well. So as you can see, the difference in speed is not that much, but this isn't really indicative of what the whole spectrum of performance looks like, and that's part of the reason why we're having this video. But as you can see, the M1 Pro is really holding its own against the 5950X, which shocked me. I won't lie. But the next benchmark starts to show a little bit of what is really going on. So if you notice, there are only benchmarks for the VS Code compile, right? But even then, you can see that both the 5950X and the 7950X3D all smoke the M1 Pro, which is kind of expected. In this particular case, for VS Code compile, it uses 4 cores. It doesn't use all the cores in the CPU, but for the cores that it does use, it leverages it very heavily. And as you can see, there's this serious performance difference there. Then if you notice, Linux couldn't compile on Mac, and that brings us to one of the important reasons why you should be careful, using the M1 Mac for development, right? Most software developers, what they do instead is they use a VM to do their compilation, or they, create, rent servers on the cloud to do that compilation. But that kind of defeats the point, right? But because of the difference in architecture, you can see that the M1 Pro, I couldn't even run Linux compile. There are ways to do it, but yeah, it's just a mess. Now, for the DaVinci Resolve project, I didn't get to run it on the M1 Pro due to like other reasons and all of that. But just looking at the 5950X versus the 7950X 3D, you can see that there is a clear difference between the two. Some of it may be due to faster memory, not necessarily faster compute, but yeah, there is significant difference between them. Like, it's not negligible, because I know I've seen a lot of people online, just say things like, oh, why do you need a fast CPU if you already have a good GPU, for editing and things like that? And the answer is no, you still need a good CPU for the encoding. I think I was using H264 or something. Anyway, that's that. But as you can see, the 7950X 3D just smokes the 5950X. So the next benchmark we're going to look at is the prime benchmarks. These prime benchmarks, so if you look at the code compile benchmarks, one of the things that, happens with code compile is that code compile isn't a pure, it's not a pure workload, right? There are other factors that affect it. Like, for example, there is network. Network affects code compile because it has to pull in packages and stuff. So for me to run all those previous tests, I had to first do the regular build. That took a longer time due to network, whatever, and then repeat the build with all the cached packages. So it may not be indicative of what sheer performance looks like. So I decided to pick prime benchmarks. What that is by a guy called Dave Plummer, absolute legend. You should go check out his channel. He's one of the guys that worked on Windows and all of that stuff. But his benchmark was just to show the difference in languages, right? Between difference in execution time between languages. So what it's doing is it's essentially running prime number, prime factors, and all of that stuff. But just looking at the benchmarks, you can see that right now, here higher is better. How many cycles of prime numbers can you calculate with the CPU? That's essentially what's checking. And just looking at it right off the bat, you can see that the M1 Pro, for single thread performance, the M1 Pro and the 7950X 3D are almost neck and neck. Now, the 7950X 3D wins outright, but it's actually quite close, and shockingly so as well. You can see that the 5950X still doesn't match the M1 in single thread performance, but the 7950X 3D is able to match it, which is not really good news comparing like a very powerful beast of a CPU with an M1 Pro, which is why I gave the recommendation I gave in my previous video that just get the M1 Pro, and yeah, it's a very good machine. But by the time you increase the number of threads, voila, you can see that now the M1 Pro can't even keep up in this case. So this is the Go benchmark, and as you can see, it's like 13 for it can only do 13,000. The M1 Pro can do 13,000, but the 5950X can do 23,000, and this is just for 4 threads, And yeah, the story doesn't get any better with more threads. If you go down to 32 threads, you can see that with 32 threads, you can't even use the M1 Pro anymore. So now just the 5950X versus the 7950X 3D. And again, the performance is pretty much what you expect. There is the changes there. So now, over to gaming. The first gaming title that we're going to look at is Horizon Zero Dawn. Here, this 7950X 3D just smokes out the 5950X. And the crazy part is this is at 4K. So, and normally you tend to be GPU limited at 4K, but the difference is still there. That's how good this CPU is. Now, granted, is there that much difference between 145 average frames to 150? Not really, but pay close attention to the 1% lows. Those 1% lows are essentially what your eye picks up when you're playing games, right? That refers to like all those stutters that occur maybe during cutscenes and things like that. And if your game is able to maintain a higher 1% loss, what that means is that you get a smoother frame time pacing, and that's very important. That's even more important than the absolute frame rates per se, which is where the X3D cache starts to shine. Looking at Returnal, the story is the same as well. You have moving from epic settings, you have huge, you get 98 frames versus 114 frames. Another thing I also want to point out as well is at 4K, the difference isn't much, but at 1080p or at 1440p, the performance difference enlarges. And what that means is that if you use technologies like DLSS, deep learning super sampling, where the game is rendered at a lower resolution and then upscaled by the GPU, you would see increased performance. In other words, with a better CPU, you're able to salvage more frames from using tools like DLSS and things like that. So yeah, that's the benchmark for Returnal. Tomb Raider, same story. Yeah, we are talking 319 FPS. That is almost like the difference between GPUs, that's almost like difference between GPU performance. So yeah, this is one of the reasons why I gave the recommendation I gave for gaming. This CPU rocks, And now, finally, the final set of benchmarks are for Stockfish, right? Stockfish is a chess engine. I have done a little bit of development with chess engines in the past, and yeah, it's something that is important to me as well. Also, even analyzing games and things like that. So, for example, if you want to analyze positions, you want to analyze it to a certain depth, and the ability to calculate all the moves up to that depth. How quickly can you calculate all the moves up to that depth is very, very important. So this benchmark is just looking at how fast can the CPU look at all possibilities on the chessboard. How fast can it evaluate nodes, which are like moves in a chess position. And as you can see straight out of the bat, even for single thread performance, the M1 Pro is no match, right? Here, I also brought in my 5800X3D. I have a dedicated system as well. And as you can see, with the single-threaded performance, the 5950X is winning, is beating the 5800X3D, and the 7950X3D is also winning as well. We are talking 3 million nodes per second, which is ridiculous. Then, when you move up to 8 threads, now the difference, there's almost like a flip in a way, because now the 5800X3D has the cache on its side. It's able to utilize that cache more between cores and between threads. And now you can see that the 5800X3D is defeating the 5950X in Stockfish evaluation. And then the 7950X3D is just wherever it is, And this is, and keep in mind, I think this is, I'm not exactly sure this is even using the CCD with the X3D with the V-cache. So that's something to keep in mind. Then at 16 threads, you can now see that the 5950X has smoked the 5800X3D. So this is a good example of a core-heavy workload, right? Flexing its muscles, showing what it can do, and things like that. And then finally, at 32 threads, I couldn't even run this benchmark on the 5800X3D. It was just taking forever because there's a lot of thread switching going on at that point. So if you have more threads than are physically available on the CPU is constantly having to switch between threads, and that penalty is so terrible that you can see that even the M1 Pro is really, really bad. Compare the M1 Pro's performance at 32 threads, it's getting 13.66 million nodes per second, whereas with 16 threads, it was able to get 15 million nodes per second, meaning that you're already getting to diminishing returns. Whereas with the 7950X3D and the 5950X, we're getting to 61 million evaluations per second and things like that. So yeah, those are the benchmarks of the 7950X3D. If you notice, it won in all categories. There are, going back to the question of the commenter, right? there are other ways as well. You can, if your application is not taking advantage of the 3D V cache, there are other options you can use, like what he mentioned with the process lasso. But if you don't want to use like tools like that, another trick you could do is to downclock since Windows usually schedules the fastest the fastest cores to workloads, you can just downclock the regular CCD below the clock speed of the X3D chip, and then Windows will always pick the X3D chip. Or you could even just go and there's a BIOS switch, you can change it. But to be honest, this CPU is so fast that it's really not necessary. And even in for the applications where it's necessary, you can even see that the tool, the AMD drivers, does the right thing of allocating it to the particular CCD. So yeah, hope you enjoyed this video. Let me know in the comments, we can have a discussion about it. What do you think about the whole video? And yeah, if you have any other thing you would like to see, any other benchmarks you would like me to test, just let me know in the comments. Peace.